Okay, so sorting, you know what it means, right? And um, in this case, we're going to do bubble. Okay, we can do linear. Then we can go for insertion sort. Then you have shell sort and selection sort. Okay. Okay. Um, so let's see this. Okay. Now, let's say you have a number. Okay. So we'll take a list for a number. Okay. And we have values like 10, 30, 70, 20, 80, 40, 60, and 50. Okay. Let's say these are your, okay. So in bubble sort, what we said, we are comparing two consecutive values, right? That's what we discussed, isn't it? We are comparing two consecutive values. So I'll compare index 0 and first. That means 10 and 30. Then I'll compare 30 and 70, whatever comes at first. Like for 10 and 30, okay, if I have to do in ascending order, then it is sorted. Okay, I don't have to make any changes. Otherwise, I will have to, change it and then compare whatever comes at 1 and so 2. So 0, 1, 1, 2, 2, 3, 3, 4, like that we are sorting.
Mhm.
So to do that, we need two for loop, correct?
Yes.
So for I in range, and if you're able to sort, okay, if you're able to sort, um let's say, if it is 3 plus 3, 6 plus 2, 8, right? You have 8 numbers here. So if we can sort 7, okay, the 8th one will automatically be sorted. So we only have to run this loop 7 times. So 7 elements. So each loop will sort 1 element. So if I run 7 times, automatically 8th one will be its own place. So for I in range, I can say len of list 1, right? So I need to run this I, okay, for entire, uh, like n minus 1 times.
Mhm.
Now this is only to repeat the whole process. Okay, then you have inner loop. Okay, instead of j, I'll put it as idx or something. Okay, so because this is what will compare the index. Okay, so I'll say for idx in range, and you can say here len of list 1. Okay, because we need to iterate through these. Now, couple of things here. If you again look back, okay, let's revise it what we have done in the last session. 1 second. So initially, okay, you have, let's say, 8 elements. You have 8 elements. Okay. So the first loop, you will have to talk about all the 8 elements, right? You're comparing all the 8 elements. In second loop, you're only comparing 7 elements because this is already sorted. Remember? Next iteration you're only doing because this is already sorted here. So if you have, like, you're comparing first and second, and if this is greater, you interchange. Okay. Then you compare this and this. If this is greater, then you interchange. You keep doing it. Okay. So either you start from 0 or you start from 1. If you start from 0, you will go all the way up to n minus 1 times.
Mhm.
Start from 1, then you will go up to the last element. Okay. So let's go back to our program. So here I'm saying range 1 comma. So I'm starting from first element. So if I'm starting from first element, then what I have to do? I have to compare if list 1 of idx minus 1. Since I'm starting from first element, I'm comparing idx minus 1 with
Mhm.
idx.
Okay.
If this is greater, right, you expect left side element to be smaller.
Mhm.
But if it is greater, we need to interchange list 1 of idx. You need to interchange. Okay, in Python, interchanging is also very easy. You can say, in other languages, you have to take a temporary variable. Here, you simply say, okay, list of idx minus 1 and list of index 1 equal to, now just interchange it. In one line, your work is done. Okay, so values will interchange. Okay, now this will go on up to the list minus 1, which is good, but second time it should go minus 1 time, right? It doesn't have to go till the end because last element you have already sorted. So instead of saying len of list 1, I'll say len of list 1 minus I. Okay, so first time I is 0, it will run up to 1 to 8 times, or 7. Index is 7 for 8th element. Next time you are going 1 less because already you have pushed the highest element to the right.
Okay.
Okay, and let's see if we are able to sorted list equal to, and I'm going to say list 1. See, list is sorted.
Sir, can you show like how the two for loops work with the diagram or something? Because I'm
Correct. I'll
confused.
do that. So let's go back to again paint. So we have said first I is from 0 to len. In fact, we could have said len minus 1 also. Okay, len minus 1, or we should have said len minus 1, because if I told you, right, if you are sorting 7 elements, the 8th element is already automatically sorted, right? So when I do I equal to, let's say you have we'll take less number to work, and we'll take the worst case kind of thing. That means we'll take elements like in descending order, let's say 40, 30, 20, 10. Let's say we have these elements. So I'm saying outer loop should run len minus 1 4 times. 4 minus 1 3 times. So 0, 1, 2, right? So I will be 0, 1, and 2, right? So when I say for loop, for loop of n minus 1. N is 4. 4 minus 1 is 3. So if you say range of 3,
Sir, I can only see the. Are you drawing something there?
yeah, sorry. So I was saying that let's take these 4 elements, 40, 30, 20, 10. Okay.
Okay.
And we have taken purposely, in decreasing order, so that, this is the, what you call as worst case, because I have to arrange every element in this case, correct?
Yeah.
We will arrange in increasing order. So I'm taking outer loop as list, len of list minus 1. So len of list is 4. 4 minus 1 is 3. Range of 3 will be I equal to 0, I equal to 0, I equal to 1, and I equal to 2. Correct? This is how you are setting the outer loop. Now let's see what happens when I is 0. So, okay, again, if you go back to the program, what we are doing is we are saying IDX in range 1 comma len of list minus 1. Okay.
Mm-hmm.
J is from 1 to len of list. Len of list is 4
4.
minus I. So in this case, our loop is going to run how many times? 4 minus 0 is 4. So 1, 2, 3. This is going to run 1, 2, 3 times. J is 1, 2, and 3. In this case, J is going to be 4 minus 1, 3. 1 to 3 is 1 and 2. So here J will be 1 and J will be 2, or IDX, whatever, inner loop, will be 2 times. Now here I'm saying 4 minus 2. So 2. 1 to 2 is just 1 time. J is going to run just 1 time. Right? Now what happens when you're running? So I'm saying if, let's go back. I'm saying if list 1, okay, the loop list 1 of J minus 1, IDX is J minus 1, right?
Mm-hmm.
Greater than list 1 of IDX. So inner loop, right? So list 1 value of J minus 1, inner loop minus 1. That means list of 0. If it is greater than list of 1, list of J. If it is greater, then interchange. So it is greater, right? 40 is greater than 30. Then it will interchange. So you get 30, 40, and the rest we have not touched. So it's going to be 20 and 10.
Mm-hmm.
We have not touched. We have left it as it is. So inner loop, first iteration is done. Now second iteration. List of IDX minus 1. So 2 minus 1, 1. So L of 1. Okay. You're comparing L of IDX or 2. So 1 and 2 is 40 and 20.
Mm-hmm.
If
40
they're
to
greater,
20.
interchange.
Mm-hmm.
So 30 will remain as it is. Now here you get
40.
20, 40, and 10.
Okay.
Similarly, next one, minus 1 is 2. 2 greater than 3.
Mm-hmm.
So 2 is this one. Greater
Yeah.
than 3 is
So
this
30,
one.
20, 10, 40.
Right. So you get 30, 20, 10, and 40. So your this element is fixed. Okay. This element fixed. We only have to compare the remaining 3 elements. That's why the inner loop has decreased by 1. We only now see here we have to sort 4 elements. So we went 3 times. Here we have to sort only 2 elements now. Okay, these two. So so 40 is left. Now you come here. L of 0 starting from again. So comparing 0, 1, 1, 2, 2, 3, 3, 4, like that. So here you'll be L of 0 greater than L of 1. So L of 0 is 30. 30 greater than 20? Obviously, yes. So you say interchange. So you say 20, 30, and rest element will be as it is, right? So 10 and 40. Then you say again L of 1, right? Because IDX is 2. So IDX minus 1. So L of 1 greater than L of 2. So 1 is this, 2 is this. Obviously, they are greater. So interchange. So 20 will be as it is. 10, 30, and 40. You see, your second element is also now sorted. We are done with I equal to 1. Now we are going to I equal to 2. In I equal to 2, you have IDX, which is 1, just 1, right? So 1 is L of 0 greater than L of 1. If L of 0 is greater than L of 1, then interchange. Of course, 0 is greater than 1, so interchange. So 10, 20, and rest will remain as it is, 30 and 40. So see, finally you got a sorted list. Okay, so this is how your iteration, okay, because when you do manually, you can visualize, okay, outer loop is going to run n minus 1 times. So somehow I have to run n minus 1. Whether you do it, some people do it reverse. Some people will say 10 to 1, some will say 1 to 10, right? I mean 0 to 9 or 9 to 0. Doesn't matter what way you are saying. Okay, so you are saying, and out this in this loop is only from, this is just to have count, because I told you, right, if you sort 3 elements, the fourth one, wherever it is correct only, right? So that's why we are going n minus 1 times outer loop. And inner loop, okay, same logic. So first you have to rearrange all 4. If you rearrange all 4 in the next iteration, you have to rearrange only 3. Next one, they have to rearrange only 2. That's it. So that's why we are saying IDX inner. And since I have to compare 2 elements, so either I go from 0 to n minus 1 or I go from 1 to n. So that I can say if you're going 1 to n, it will be IDX minus 1 greater than IDX. If I had gone 0 to, so if I go back here, so if I, instead of saying 1, if I had gone from 0, okay, then I would have said len minus 1. And here instead of minus 1, because IDX is always 0, I would have said IDX plus 1.
Okay.
Right? Because I'm starting with 0, so 0 is taken care by IDX. I have to check next element, so I'll say plus 1. Right? So that's why you say here IDX.
So is this bubble sort?
Bubble sort.
Okay.
You are sorting, you're comparing next element. Okay, still you get same answer. Bubble. This is how I remember. BB, bubble, next to next. Okay. So, you 0, 1, 1, 2, 1, 2, 3, so on. Okay. This is your bubble sort. Next is called linear sort. Okay. Here, instead of comparing the next element together, we compare first element with second, first with third, first with fourth, so on. Okay. So let's go back to our again description here. And let's say we have same set of elements. Got right? I can delete this one, right?
Yeah, yes.
Okay. So let's say I have this. So what it linear sort says is you pick index 0. So index 0 is 40. Compare with 40 and 30. Yes, interchange is required. So interchange. So it becomes 30 and 40 now. Okay. Now this is fixed. So now you compare 30 and 20. Yes, interchange is required. So 20, 40 remains as it is, and we are interchanging with 30. So 30 came here, 20 came here. Now you compare with, 10. So 20 and 10 change is required. So 10 comes here, 40 will remain here, 30 and 20. Okay, you saw that in bubble sort, what happened? The last element was fixed. Here, first element is fixed. Because you're comparing everything with first. You're comparing everything with first. Okay? So this is your I equal to 1 or I equal to 0. This all happened. Now when say I equal to 1, okay, this now the one that you're checking, right, will come to the ones place now, because your zeros place is fixed 10. Now you have 40, 30, 20, right?
Yeah.
Now you compare 40 and 30. Yes, change is required. Now you compare 30 and 20. Yes, change is required. 20, 40, 30. So when I equal to 1, this is the situation. Second element is also fixed. So here, how many times I should run?
Uh, 3 times.
Correct. N minus 1 times, 3 times, right? Same logic. If you fix 3 elements, fourth element is already automatically fixed. So I should run. Okay. Now from where to where J should run? Here J is running from, if index I is 0, then you don't run from 0. You run from 1 to n. Okay, you run from 1 to n. If I is 1, then you run from 2 to n.
That
You
was
have to
the
go all
previous
the way
one.
up to n, but you
Hello.
have to start from next number.
Yeah. Sir, you're breaking up.
Yeah. Just give me. Now it should be better.
Okay.
Yeah. So when I equal to 0, your J is running from 1 till length of the list.
Yeah.
When I equal to 1 now, second iteration of I,
It'll
0
run 3
is already
times.
taken care of. So you don't have
So
to
from
worry about
1
it.
to end of the list. Yeah.
2 to the end of the list.
Oh, okay.
Right? I is at 1. So you
Okay.
should go from 2 to the end of the list.
Okay.
Okay. Very similar to bubble sort only. Okay. Only difference is in bubble sort, you're comparing next to next element. Here you're comparing first with the rest, second with the rest, third with the rest. Okay. So in terms of complexity and everything, it's exactly same as bubble sort. So if you go back to the program, okay. So I copy the same list here, and I copy the same print here. Let me put here bubble sorted list, linear sorted list. Okay. Now the logic. Okay. Let me copy and paste same thing, and we'll change step by step. So what did we say? I should go from 0 to
End of list.
end of the list, right? So sorry. So it starts from 0, and you don't have to go to the sorry. You don't have to go to the end, because if you have sorted n minus 1, the last element is already sorted. Correct?
Yes.
So that's why I don't have to sort the last element. I just have to sort last n minus 1, second last element, up to second last element. Whatever is left in the last is automatically sorted, because one element there is no need to sort, right?
Yeah.
So there's no change here. Now here there is a change, because you are not starting from 0, but you are starting from I plus 1. If I is at 0, you are comparing 1, 2, 3, 4, so on. Okay. If your I is at 2, you're comparing from 3. So that's why I plus 1. And here, okay, you have to go till the end. No option for you. Right? So you have to go till the end, so that all the elements are compared with the first element. Now you tell me here, what should I write?
If list one
So
shouldn't
see,
it- yeah.
what we are doing,
Mm-hmm.
we are saying, okay, so we are saying compare first element. What is the first element? I,
Yeah.
right?
Okay.
So it should be I. You're comparing first element with the rest. Then next round, I becomes 1. So first element with the rest. Then becomes 2. So this outer value goes along with I.
Mm-hmm. So
Now
it's
the
basically if
inner
list of one of I greater than list of index, that's it.
index, exactly. So index will go from I plus 1 till the end.
Yeah.
Okay. In that case, you simply interchange. So I index becomes, sorry, index I.
Mhm.
Okay. Now let's see if this works. Yep, it worked. Okay. That's
Mhm.
all. These are used. This is also called as simple sort.
Mhm.
Okay. This is also called as simple sort. Okay. This is how your
Mhm.
linear or simple sort works. Okay. We'll do one more today. It's called merge sort. Okay.
Mhm.
So let's improve our complexity. We'll go to the merge sort. What sort is interesting? Okay. So let's see here. Let's say you have same 4 elements. Let's say you have 40,
Mhm.
30, 20, 10. Okay. And let's make it one more, we'll add. Okay. 5. Or let's make it 35 and 5. Little bigger, so it'll take little longer time. Okay. So you have these elements. So
Okay.
merge means, okay, it's called divide and merge. Okay, it's called merge. Merge basically means you are dividing and then you are merging. So it says first you divide them into single individual.
Mhm.
And the logic of sorting happens while you merge them back.
Mhm.
Okay, so you have lots of numbers to sort. You first put them separately. Okay, so see, if I give you coins, right? Okay, let's say if I give you coins of all denomination, 5 paisa, 10 paisa, 20, 30, and I ask you to put them in order. So what will you do? First, you will spread them all, isn't it? So that
Yeah.
you are able to see each one of them. And then you will pick the lowest, second lowest, third lowest, and put them together. Something similar, something similar.
Sir, I have a question.
Yes.
What's the point of all this sorting if like in Python there's already the sorted function?
Yeah, so see, that's what I told you yesterday also, if I not yesterday, last class also. See,
Mhm.
all these things are there. We just have to call a function.
Okay.
But in the interview, they might ask you, or you might have to improve your existing algorithm.
Okay.
Okay, the chances are very less. Okay, and not chance in the sense, the role that you will end up getting. Okay, let's say if you're developing something from scratch.
Mhm.
Okay, there, that's when you will use this logic. Okay. 80% of the work, application development, you don't even know.
Mm-hmm.
Okay. So that's why if you see, you don't have, you have programming classes, but you don't have data structure classes. Because, you can use these inbuilt functions.
Mm-hmm.
But when you are working at operating system level, okay, if you are working at very, low level of system level,
Mm-hmm.
then this becomes important because you have to implement this.
Okay.
Okay. So if you are at operating system or let's say database design, okay, this kind of application, then you'll have to design this. If you become a say data scientist and you are looking at the developing this code, you'll have to design this. Okay. But those roles are very less. Most of the roles are application development. You develop
Mm-hmm.
and you develop website, you develop, the applications basically, right? So there you just have to call and use. But when you go to low level development work, that's when. But for interview also, this is important.
Okay.
Okay. So all these top companies, right? They'll definitely ask you questions on data structure.
Mm-hmm.
Okay, because uh, somebody had developed it, right? When
Yeah.
you're using bubble sort inbuilt or it is sorting, somebody's already developed it, isn't it?
Yeah.
Yeah. So that's what. So let's say you get into Facebook and Facebook decides to develop a new programming language. Okay. So, see these guys like for they don't go with this normal programming language. They all have some limitations. It will not work with the kind of data that you have with, let's say, Facebook or Google. So what they do, they were using Python before, okay, and then they made Python public so that they no longer use Python. So they made it public, some of those tools. Now, classic example is TensorFlow. TensorFlow was used by Google. Now they have moved to something else. So they made TensorFlow public. You can develop these deep learning algorithms with TensorFlow already developed. They use it, they developed it, they worked. And now when they move to something else, they say, okay, public, you have TensorFlow. You can also learn to develop deep learning algorithm. So what we are developing now, okay, Facebook probably was developing, Google was probably developing 10 years back, 20 years, 15 years back.
Okay.
So in these companies, when you get into their development team, you will have to develop a new language. Okay, these concepts. Okay, so now talking about merge sort, you are breaking into multiple individual, like you're doing half, half, half until each element becomes one. So what is half of 6? It is 3, right? So you are breaking at 3 here. So after first merge, or not merge, sorry, divide. Okay, you are still dividing. Okay, merge, actual logic has not happened yet.
Okay.
So you are dividing. So you get 35, 40, 30, and 20, 10, 5. So the logic here goes is, it's easy to sort 3 elements than sorting 6 elements, correct?
Yeah.
So let's divide into 3 elements first. We'll sort the 3 elements. Okay. Now this 3 element is again divided into half. So half of 3 is 1, correct?
Okay.
1.5, you will
Yeah, you'll go round down. Right?
1, yeah. So now you divide at 1 here. So you get 35 as one group. Okay. 40, 30 at one group. So it's easy to sort one element or 2 elements than sorting 3 elements. So again here 1. So 20 will become one group, and 10 and 5 will become another group. Then now again you sort. Again you divide. Again you divide. So 35 will remain as it is because it's only 1. So there is nothing to divide here. And your 40 and 30 will become separate.
Mhm.
Okay, here again 20 is 1, 10 is 1, and 5 is 1. Okay, so
Yeah.
this is dividing until you reach to individual level. Now actually the logic starts. Okay, so logic starts with two elements here. Okay, now when you look at 40 and 30, okay, anyway 35 is 1, so it will remain 1.
Yeah.
40 and 30, what happens? Interchange 30 and 40.
Okay.
We are doing ascending order, let's say 35. We are merging now. That's why it's called merge sort. We are merging now. So we have merged these two. Now 20 will remain as it is. Now 10 and 5 will come here, 10 will come here.
Mhm.
So we have merged them together. Now, again, we have to merge them together now here. So 30 will go, so 30 is less than that. So 30 will keep moving to the next till it finds its position. So when it encounters a higher value, that's when it stops. 30 lower, okay, move next. 40, oh, stops. So it gets added between 30 and 40. So you get 30, 35, and 40. So now they are merged into a sorted list. Same thing here, 20. 20 will go here, 5 is less. Go here, 10 is also less. Goes there, end of the list. So it gets added at end of the list. So you have 5, 10, and 20.
Mhm.
Now final merge will happen. Okay, okay. So you take 30, 30 will go here. So you get 5, 10, 20, 30. 35 will go after 35. 40 will go after 35. So it compares and goes. So you'll have 5, 10, 20, 30, 5, 10, 20, 35, 5, 10, 20, 30, 35, 40. So finally you get 5, 10, 20, 30, 35, 40.
Mhm.
Okay. So divide and then you keep merging based on the values. This is your merge sort. Okay. How does it work? Shall we do the code?
Sure, sir.
Okay. So let's go back to our programming. We will take list 1 here. Okay. Okay. Now, okay. So now you can check the list. Okay. If len of list 1 is less than 2, that means you have either one element or no element. Then this is the sorted list, isn't it?
Mhm.
Merge sort. It is already sorted, so we don't have to do anything. But if it is more than 2, okay, then what? Okay. So first, we are dividing this list into left side and right side, right?
Mhm.
We are dividing this list into left side and right
Right.
side. Correct?
Mhm.
So how do you divide into the right side? So I'm going to say center equal to, so whatever list that you have given, that list, if you divide by 2 becomes center, right?
Yeah.
So this it becomes,
And the list 1/2.
yeah, okay. Len of list 1, double integer, right? It doesn't accept decimal point. Even if it
Mhm.
is 4/2, 2.0, don't accept, in the index. Index has to be proper integer value. Okay, 5.0 is not integer. So even if you give 5.0, it's going to
Give
give
a
error. Okay.
yeah.
Now, left side and right side.
So do we just say if no, wait.
Now, here you see, okay, we'll have to use function.
Mhm.
Okay, we'll have to use function because the function will be called multiple times because you are doing sorting multiple times, isn't it?
Mhm. Can't we just like iterate through the list until the center and put that in like a temporary list or something, and then do that for the second half also?
No, so if you do that case, then merging becomes difficult
Okay, okay, okay.
because merge, if you see that the route that we followed while dividing, same route we followed for merging.
Mm-hmm.
If you
Okay.
go selection wise and keep breaking it, okay, you are able to break it, then merging will not happen.
Okay.
So you have to follow same path. It's like the way you go to a city, you come back using same path. It becomes easy. Your loop can work on it.
Okay.
Okay. So what we'll do is we will put this in a function. We'll put this in a function here.
Okay.
So I'm going to say something like merge sort or something. Okay. Forgot to record.
Oh, okay.
So I think we'll just quickly revise. So this is what we did here, right? In else, we said center, and then we are creating two lists, left list and right list.
Mm-hmm.
And in left list, you're adding from beginning till the center, up to center, right? In
Yeah.
right list, center and up to the end. Okay. And then you keep dividing this. We have to keep dividing until we end up getting individual values as a list.
Mhm.
Now we have to merge them. So merge is where the merge sort logic happens. So in
Mhm.
merge sort logic, what we did, we are taking two elements, left and right. Left is a list, right is also a list. Now, if they are not empty, if right is empty, then left itself is the output. Okay. If left is empty, then right itself is the output. But if they are not empty, you have to merge them based on the value, right? The
Yeah.
least should go to the left side and higher should go to the right side if you're doing ascending order. If you're doing descending order, reverse should happen.
Yeah.
So I have taken a result as an empty list, and then I'm comparing the values left. If left is greater, then right should get added to the result.
Mhm.
Otherwise, left should get added to the result. And then once you add the left value or the right value, then remove that value from that left right list. So we are removing it. Finally, when you have only one set of values left values. So you keep, so if left is 0, then the right is added to the result. Or
Mhm.
if right is 0, then left is added to the result. And that's your final output.
Mhm.
And when we ran, this was our original list, and this is what we got.
Yeah.
Okay, we'll
Mhm.
end it here.